Hello, welcome to today's webinar from Push Technology, Extending Kafka for Internet Scale Distribution of Data. I'm Mike Eister. I'm a solutions engineer at Push Technology in North America. I have 25 years of architecting and working with many organizations towards their integration and broker solutions and analytics. Worked at companies like HP, Oracle, Informatica. So in today's webinar, we're going to use a specific use case for demonstration of data, event data, as it flows through Kafka and Diffusion's value for distribution of that data. And so we'll start out by an introduction of exactly what that foreign exchange use case is. Just as a preliminary note, Diffusion can be used for any use case. We'll go through an event-driven architecture, take a look at what constitutes an EDA, and then we'll look at extending Kafka with Diffusion. So let's start with our use case, foreign exchange, FX. It's a generic term. It's used by worldwide institutions, and it's used to exchange or trade currencies of different countries. You'll see my data pointing quite a bit between Australia and the US. There exists no single trading center, and the market operates 24 hours a day. So as we start to look at foreign exchange data, we start to look at the uses and use cases of the value of that foreign exchange data, we start to see the different types of consumers and applications that can benefit from FX data. Again, FX data has currencies inside of it, it has tiers inside of it, and it has the ability to enable different levels of service to different types of customers. Customers may be the dealers themselves, foreign exchange dealers. It could be central banks that offer trading capabilities against FX data. It could be the retail market participants, people whom are the customers of the brokers themselves, but are only allowed to see a certain section of that data. Or maybe there's some hedging going on. There are multiple different types of consumers and applications for our foreign exchange data. Some of these challenges are, there are high volumes of data. There are multiple sources for this data. It's in different formats. There's multiple different varieties of that data. And then I'll say the third V here, the velocity or performance. Requirements for these platforms to be actionable on the data. That means delivering in real-time event data with minimum latency and highly available, fault-tolerant, and network-tolerant. We also look at many organizations who now are adding new markets. If we step a little sideways from the use case and we look at maybe commodity trading, and we look at instruments inside of that, some organizations can have well over 10 million, 20 million different instruments, different stocks, different data about each one of them. And adding these new markets in new areas for new instruments are constantly being performed by these organizations to drive more value for their end customers and increase revenue. They also find themselves through processes of M&A, through the acquisitions of gaining redundant systems, or introduction of new technologies, modernizing those technologies. And as that they're adding these new platforms or consolidating them, excuse me, there are requirements for how do they merge that data, how do they still distribute that data in complex environments. So the data itself can come from public channels, it can come from official sites, it can come from commercial offerings. Many organizations that work with FX data use technologies such as feed handlers. They connect to the exchanges directly. They may have internal processes that are generating data as well. These organizations could potentially have well over 200 different feeds and sources of data for their FX data. Introducing the event-driven architecture, connecting these sources, consuming the data, transforming and enriching that data, and deriving the exact view of that data for consumption by those consumers, and then delivery for that consumption process are capabilities that organizations deploy inside of their EDAs. Now, when Gartner looked at the EDA landscape that's out there are 3 primary broker applications that participate inside of an EDA. There's the queue-oriented broker, which deals very well with multi-protocols. It's a flexible topic structure, meaning that they can create new topics very easily. And it's in situations of where you could potentially have thousands of different consumers to it. Now, the log-oriented broker, where let's say Kafka sits squarely, has the ability to deal with large volumes of streaming data. It stores it in logs on disk and provides retention capabilities for potentially access at a future date, for potentially performing some difference calculations and analytics and replay processes. And then there's the subscription-oriented broker itself, where now we're starting to develop subscriptions to that data, accessing that data. This is more of a memory-based type of solution, where distribution of events are at scale, supporting a large number of concurrent users and large volumes of data streaming. And as we see here in the notes, practices and standards and approaches to EDA, they're all diverse, and they all claim to do pub/sub. So it could be very foreseeable that there is some misunderstanding about the roles of these different brokers in the overall EDA architecture as to what is the most efficient platform to use, potentially introducing a hybrid architecture where a couple of these or all 3 of these are used in different processes of your overall EDA architecture. You may ask why. If one can perform everything, it's often not very efficient, introducing additional code and infrastructure, process, and high costs to do that. And so here on our second point, choice of the event brokers is critical because of each event broker's specific capabilities will dictate the architecture and design of your EDA. Misalignment of requirements and capabilities, once the project goes into, let's say, development, design, deployment, is painful to architect into a capacity that that particular log-based or queue-based or subscription-based broker application is not necessarily the best fit for. And once in production, it is very costly to resolve that, to modernize it back into an architecture where you are, where your organization is saving money and being much more practical. I had worked for an organization in the past where we did try to develop and deliver real-time solutions, and it became extremely costly. And in that case, it actually was not deliverable. It didn't meet the requirements of the customer. And so when choosing an EDA architecture, it's critical that you use the appropriate broker for the appropriate use case. Now let's get into a little bit deeper. So we have data. We have our 3 different broker technologies inside of the EDA. Now let's introduce some more diversity. Organizations are deploying inside of Azure. They're deploying inside of AWS. They might have multiple deployments in multiple regions with multiple VPCs. They may have SaaS offerings, software as a service. They may have a database as a service. They may have Diffusion as a service, which is available. They may have on-premise deployments for regulatory requirements and data privacy issues. They may have multiple geo-based locations for their operations and processes. And then you start to look at this hybrid world and combinations of these. Now going across production, test, UAT, disaster recovery, and HA. You can start to see where now you start to deploy your EDA. It becomes a very challenging landscape, and it begins to scale and grow very rapidly. It becomes more and more complex. As we go kind of to the right-hand side of the screen here, what I'm trying to visualize is that each different broker has different requirements. They have different compute requirements. They have different application and program and API requirements, the large number of applications in some cases to support a specific broker grows exponentially. And they all have different database and storage requirements themselves based upon what that customer or engineer or architect is trying to do in that portion of their application and their environment. And as you can see, potentially for a streaming environment, that it requires less compute, that it requires less coding, and that it requires less storage at a significant level, saving on TCO or managing TCO better, more appropriately. And so when an organization looks at this, when they look at the build, they look for a holistic platform with low code features to simplify the coding efforts. A platform with the ability to define rules within itself, to very rapidly create new views of that data, to manage that data, enrich that data in those events, and deliver those. Looking at performance, low latency, requirements from consumers to keep prices current, cost, remove the cost from redundant applications, from redundant infrastructure for high compute and storage requirements, for, let's say, in the cloud, for costs and charges, for network traffic. Okay, so all of these are being managed and maintained. And it's very easy when deploying an EDA to see how that cost could potentially spiral. And then the control side of it, right? Control of the transformation and enrichment of data, control of delivering the right data to the right consumer. In many log-based broker solutions, much larger data payloads are delivered to those end consumers because they simply cannot deliver the fine-grained services without custom coding to stream that data. And then secure this through the journey of the data through the entire process. Role-based security, not getting locked into a single vendor's or single infrastructure's security implementation, being able to leverage your existing security infrastructure and then scale that and easily be able to turn that on or off for specific security rules without causing inconsistencies or outages inside of your platforms, such as when maybe a rebalance has to happen as consumer groups are changing. So when we look at diffusion and introducing diffusion, the intelligent event data platform, diffusion is a holistic hub-sub platform for streaming data. The three primary components to diffusion: on the consumption side, our gateway services have the ability to consume data through a number of different APIs and a number of different adapters that you will see today. The adapter that we're going to be showcasing today is our Kafka adapter, which is available for all environments. It's available for in the cloud. It's available as a service as part of the Diffusion cloud product itself. And we can consume this data and actually have some pretty cool features with consumption of that data. Let's say the data is large. We have the ability actually to only send the deltas, to shorten the size or shrink the size of that data. We also have the ability to throttle the data that's coming in. Maybe the volume of data is just too significant. So we provide that ability too. I've been talking a little bit about wrangling, and that's the next part of our platform, beyond the gateway, is on the application tier that Diffusion offers a low-code environment. A lot of our customers are actually deploying headless clients to consume data because all of the transformation, all of the logic is inside of rules within Diffusion itself. And so now consuming our data, third part, uses the same APIs, SDKs, and adapters that are available in all common languages to begin to subscribe to that data so that Diffusion can stream that data. Now we do support both publish, subscribe, which you hear across all broker technologies, and also request response, seamlessly setting up an environment for a consumer to specifically request data from a service that is registered and will specifically respond to that. So both patterns are supported by push technology. So let's get back into our use case a little bit. So the sources for the data may come from multiple different locations. So many different feed handlers, for example, provide on-ramps for that consumption based upon different technologies. And so they may be web services, they may be REST-based, they may be FTP or SFTP types of services delivering files. It could be that there's a dedicated connection, potentially, let's say, to an exchange, where now we're using potentially proprietary in-house applications to collect data as well. And through this consumption, it's going into the different brokering technologies based upon the use case and the capabilities. Some feed handlers may only deliver data to Kafka. So there'll be some requirements basically on the consumption side based upon the sources that you're using. And so we look at primary features such as multi-protocol, being able to support maybe MQTT or other types of technologies, HTTP, the web services, etc., retention and replay, for non-repudiation, auditing, logging capabilities, and then on the distribution side, for very efficiently distributing large volumes of data at scale to a large number of concurrently connected users. So let's take a deeper look then at the FX data as it comes in to Kafka. And so with Kafka today, they have a number of mechanisms to load data in. There may be the Kafka Connect framework itself, and vendors out there who have created adapters using Kafka Connect to load data into Kafka. There could be custom code. There could be custom code, again, that's using Kafka's pub/sub capabilities. And there could be use of the Kafka Streams APIs, which sit on top of the Kafka pub/sub capabilities. Now, as this data is coming in, it's log and disk based and focused, and it's large volumes of data for those downstream processes and applications. So classic uses are for analytics to get to that data from Kafka. But the topic structure is fairly flat. Kafka offers in reliable fashions per cluster the ability to potentially manage up to about 20,000 topics per Kafka cluster. And so what we find is that a lot of data is streaming into common Kafka, generic Kafka topics for downstream processing by server or client applications. And again, Kafka does support that pub/sub capability. And so Diffusion offers the Kafka adapter. The Kafka adapter seamlessly integrates with Kafka, and it integrates with Kafka both in the cloud and on-premise. Now that we can define that, and I'll show that in a minute, now that we have integrated with Kafka, then we can provide all the value and rules inside of Diffusion and distribution capabilities. So this is a screenshot from our Kafka connector adapter in the cloud. And you can see that we can both ingest and we can broadcast to Kafka. We can define the consumer group. We can define which Kafka brokers we're going to work with, whether they're local in the cloud. We could define the paths, the topic path for Kafka that we're going to work with. We could even use regex to start to get to some specific Kafka topics themselves. We have advanced capabilities. We do work also with SASL and the Kafka security model itself. But we do have the ability as well to connect into Kafka and have reconnect, etc., types of parameters for the operation of Kafka and consuming that data into Diffusion. Now, likewise, in addition to our adapters, we have APIs. And these APIs are available in common and popular languages that are out there. We have Java, we have .NET, C#. We have JavaScript that could be deployed as part of a web page or application itself, or Node.js. We have Python APIs and C. And then also this is part of the extension of Diffusion, or extension of events via Diffusion. We support, I had already mentioned the web, but also mobile natively. And so we support both Android and Apple iOS. Now, using our API is consistent across all of these different interfaces. And I kind of describe it as a three-step dance. We basically connect to Diffusion, not that I'm a dancer, but we connect to Diffusion. We create the topic, this channel of how we're going to organize or begin to organize this data. And then we simply send the data. Now, we support a number of different data types, such as string, such as binary, such as JSON, etc. And so from the consumption side, I just wanted to summarize what we've spoken about so far, is that event-driven brokers can all pub sub. However, they're all functionally different. Diffusion both publishes into and subscribes from Kafka using an easy to configure adapter. And Diffusion is a low-code platform, eliminating custom code found in Kafka or other log-based or queue-based applications today. And we'll see a little bit more of that coming up here. So if we go back to our FX data, we have this FX data. It's coming from multiple sources, but there's some common themes about this FX data. It has currency pairs in it, which basically are the prices of, let's say, the Australian currency and the US currency. And there may be different tiers. And so these different tiers then have different values of Australian or from one country's currency into the next. Now, these tiers, they're based on the nature of the business. You know, are you dealing with options? And organizations, brokers, they have different types of clients that they work with and different prioritizations. And so with these, there may be lower requirements for smaller exposure and conditions. The price difference between the different currencies is a little bit closer, or they may have higher requirements for larger exposure based upon their relationships. And these are called spreads. And so spreads can be narrower or wider, you know, depending upon what the currency is, the time of day, what the economic conditions are, and even the trader credit profile and other properties. So when we look at this data, we can start to see that we have the timestamp for the data. We're starting to see those currency pairs and a timestamp for that currency pairs. What we're not seeing, though, is a clean organization of what the tiers are. They're just there. We're seeing multiple arrays. We're seeing multiple organization levels inside of the data itself. We're seeing the pair name. And here in the pair name, we're seeing Australian to US dollars. And then we see this data is repeated. And again, this could come from a large number of different sources. The data format can vary, and it's continuously being updated and changed. Now, this data may flow in to Kafka today. There could be hundreds of applications writing to common topics. Remember those limitations from topics inside the Kafka side, which becomes very important when you look at it from the distribution requirements of your overall EDA approach. So hundreds of applications writing to common topics, hundreds of other applications reading data from the topics. And these topics can exist in various Kafka locations. And so what I'm trying to depict here is that you may have some currencies from some feeds coming into one specific Kafka cluster. Or maybe you have different lines of business, organizations, and applications that require different Kafka clusters. Remember, changes inside of Kafka often could potentially impact the operation. Application changes, security changes can impact the operation of that Kafka cluster. So you may isolate your Kafka clusters between different lines of business, departments and applications, really increasing the total number of Kafka clusters that you're potentially working with today. Now, increasing the number of Kafka clusters obviously increases the infrastructure needed for it, but it also introduces the requirements for custom code to start taking data from these larger pipes and to be able to segment that data into smaller Kafka topics and downstream Kafka clusters. And so we start to see, and in conversation with my customers, we start to see that organizations have multiple Kafka clusters in their pub/sub types of architectures to both get the data in, custom code to organize that data, and custom code again to begin to deliver that data itself. And so that kind of introduces the next step in offering from push technologies to fusion, the ability to wrangle, the ability to represent data topics in topic trees. What you see on the right is that I have a topic tree. I've organized it underneath pairs, and now I have individual topics, what we call reference topics, for each different currency. I seamlessly did this with Diffusion's topic view capabilities by providing rules that dynamically create these topics. Now, inside of these topic views, we create a specification. It's one line of configuration, and it's using a rich set of features from Diffusion, such as the Diffusion expand, which is what was used, as you will see a little bit later, to create this pairs root topic with all of the different currency subtopics. We also have the ability to use pathing capabilities to explicitly go after a specific level of a topic tree itself. You have the ability to map specific values, specific elements inside of that topic tree. You have the ability to organize by what's contained within those topics using our scalar features. As mentioned earlier, you have the ability to throttle data as it comes in. You have the ability, maybe for different tiers of consumers that may have different SLAs associated with them, to delay that. You may want to create reference topics that are stored in memory. They're highly accessible, amazingly fast, with our preserve capabilities for consuming data in real time that's flowing through your EDA as events. So let's take a closer look at our data modeling and at our topic trees. So the data itself has 10 currency pairs, okay, like Australia to US, each one with 3 different pricing tiers. Inside that pricing tier, you can see that the values are a little bit different from one tier to the next, different spreads. And so it comes in, and what's on the left-hand side here represents only one pair. Now imagine getting hundreds of pairs, and imagine continuous update of that data, streaming with millisecond type of precision. So now you start to envision that data and look at that data as how it comes into Diffusion. Now I've seamlessly connected into Kafka using my adapter. It's subscribed to that Kafka topic, the high-level Kafka topic, what I'm depicting here on the right-hand side. The adapter then publishes that data into an incoming topic for Diffusion, what I've called Kafka local on the right-hand side. And then I seamlessly map to my FX topic, to my incoming FX value. Now, it may appear that data is being replicated here, but let me assure you that it is not. It's only coming in one source, and we are creating views of that data to maximize our performance. So let's look at the event workflow of how we're consuming this data. So again, we've got our FX topic data coming in. We can see a value, the current value on the left-hand side of what that data begins to look like or does look like. And then we've already completed steps 1 and 2 of collecting that from Kafka and mapping that to my incoming FX topic itself. Now my next step is I want to segment this out. I may have consumers that are only interested in the Australia to US dollar currency rates. And so I create what we call a topic view and a specification here. And you can see I'm performing a map in that center box of incoming FX to a new topic new root topic called currencies, and I'm expanding. And I'm expanding what the pairs are because that's how my data is named. It's named as pairs, and it's called, or values are, like that Australia hyphen US dollar that we see inside of our root topics on the right-hand side. And then we start to organize this and name them. Apologies, the pair name names it. The data is organized by pairs. So our next step for different types of consumers is that I want to map currencies to my different tiers. And you can see now my data tree, my topic tree, becomes more fine-grained. My filtering is becoming more fine-grained. My consumers can specifically request the data that they're after, Australia to US dollars or tier 0. This applies to many different broker or FX dealer types of use cases themselves. The last one is that I want to create tier pricing. Now, if you notice, this one is not using the expand function. We're using our map function, and we simply reorganize the data. Now, this use case is very valuable for where maybe a broker wants to extend services to their end customers and their end customers to begin subscribing, but their customers are only associated to very specific tiers. But their customers may want to see all currencies by tier. So I am a customer, I'm tier 0, and I want all currencies. And so now I can subscribe. I can subscribe specifically. And on the top right-hand side, you see the topic name. Right now it's priced by tier /0 /Australia hyphen US dollar, okay? Or maybe I want to subscribe to everything that's underneath tier 0. So I can become very specific as to the data, fine-grained as to what I want to subscribe to. Now, the other beauty here is that I'm managing this centrally inside of Diffusion. I can change these rules inside of Diffusion without having any requirements to update any code or include any code on the client side. I can dynamically control the content of the data that's being streamed and distributed to my end users at scale in high volumes centrally. So our summary for wrangling is that our topic views are powerful event data enrichment and segmentation services. We enable highly performant live data models in memory versus disk. Now, this live data model concept is important. We have this notion of time series topics, of where we maintain the integrity of the data as it's being published and subscribed to. You may have multiple values. You may have history of different values of currencies over a period of time. Now, this is important because it's highly performant and in memory. We have the ability also to persist that to disk. But it's important in that you're not introducing additional intermediary process and access to data on some storage to begin comparing your historical values for your business use cases. Okay, so this notion of a live data model and the features that come with it in memory, such as our time series capabilities, differentiate a distribution platform, distribution, subscription, broker, such as Diffusion. Now, Diffusion expands, not pigeonholing Diffusion there. Diffusion does have capabilities in some of the other broker technologies, okay? It's just inside this one use case. Now, Diffusion expands the number of topics available in Kafka clusters as well. So we may see clusters that are up to 20,000 different topics, and inside of Diffusion, the number is fairly limitless. You can potentially have situations of where you have hundreds of thousands or millions of different topics in a much more manageable infrastructure. So let's start talking about distribution of the data. Massive scalability, millions of topics and connections, as I mentioned. There's a difference between currently connected users and load, and the ability to process large volumes of data, and the ability to have highly performant with millisecond types of latency. There's a difference between understanding whom is connected and whom is not connected. What is an active session? What is not an active session? What happens when a session disconnects? How did it disconnect? How can we improve the reliability of that particular connection itself? Efficient use of bandwidth. Diffusion offers a patented delta streaming capability where we reduce the data sizes themselves by up to 90%. We even have some situations of where customers are seeing 99% data size reductions, really reducing the infrastructure needed on the compute side, storage side, and very importantly, on the network side. Real-time response, latency in milliseconds, simplified client software, again, that headless kind of approach, but the consistency inside of the APIs, easy to use adapters, and again, the multi-protocol capabilities across REST, HTTP, different patterns, MQTT to reach some of those IoT types of devices. And so we're introducing the real-time event broker, critical real-time streaming capabilities, a deep hierarchical topic tree, as I described earlier, as you see, that you could potentially dynamically create through our topic views and those rules. You're not coding these things, you're configuring it, and then the system dynamically creates these topic trees. And by the way, if somebody asks for a topic that doesn't exist, we have process to understand when that happens, and we can instantiate services to take corrective action when somebody's asking for data that doesn't exist inside of these topic trees. It's totally dynamic. And then security and fine-grained and role-based security against any of the data that's flowing through diffusion. Now let's talk a little bit more about security, okay? So there's a lot of information on this slide. And so we offer a role-based topic level security. And so here on the top side, we're showing how we start to begin to create our roles. Now, I may have, let's say, Australia to US dollar currencies, or maybe the euro to US dollar. I may have requirements to secure by tier level. So if I have, let's say, shared services with my end customers that are entitled to tier 0, then I want to have rules against that. I may want to have security that allows the ability to select that data, right? You can't really do anything until you can select that data. Maybe specific users, different operational, different DevOps, et cetera, different environments, have the update capabilities, modify capabilities. Maybe we want to lock that particular topic, that particular data to only one consumer for a specific critical use case, and I can perform session locks on this data, okay? Maybe I have handlers that are registered inside of our framework to act upon specific events that happen, specific conditions. I can secure that as well. Now I can add principals. And by the way, we can point to external repositories for users as well, okay? We have integration, let's say, with SSO, single sign-on. And I want to, let's say, start associating roles with my different users. We have full role inheritance as well. And so if you're part of one role, you could potentially inherit other capabilities as well. You may have different users for anonymous types of activities, operations, your analytic processes. You may have brokers with different capacities and access to different paths to fine-grained or coarse-grained security rules or roles. You may have client prioritization, okay? And again, this could reside in other environments. Now, all data that flows through Diffusion is TLS 1.3 enabled and encrypted, okay? You have the ability, I think there's about 30 of them or so, selectable ciphers that you can choose as features through TLS, okay? So for those following Kafka, you know that you may have observed that the different levels of support for TLS varied by versions of Kafka and deployments of Kafka, and over periods of time based upon the standards body that manages Kafka itself. And you may have noticed some delays inside of that. Push Technology stays in front. Very agile organization. We support TLS 1.3 natively out of the box. That is configurable. Now let's talk about the handlers that I mentioned earlier. You may have authentication processes, right? So today inside of Kafka, there's a specific security framework to use, and then that's it, right? You're just restricted to using that one framework. What if you did want to integrate single sign-on, right? What if you wanted to get out of, the SASL types of requirements, but also wanted to get into SSO? What if you want to do lookups inside of LDAP, right? Active Directory. What about cloud with JWT or OAuth types of processing? And what if your particular user's credentials only are available in one of these different environments? Do they immediately get denied access because they're not commonly defined across all of these different environments? So we can create authentication chains using our authentication handlers. Now, these handlers are part of a framework that natively are part of Diffusion. Okay, this framework, there's instrumentation for it, there's process for it. It's very easy to plug in applications and processes into our handlers. Okay, so we introduce authentication chains and post-processing. Maybe this particular user is only identified in single sign-on, but they're still entitled to authenticate and then be authorized for currency, Australian to US dollar types of data. And we have session handlers. And we have one customer where it's absolutely critical that they know whom is connected and that particular individual when they are disconnected. And so we have session handlers that basically, again, part of our framework, plug in, and they provide vision into what my connected sessions are. You could imagine as you start to get into large numbers of users, right? Everything here has to be API driven and can be programmatically managed, right? Instead of going through a specific interface, right? So everything here is through APIs and it's also visual, okay? But now with the session handlers, we give visibility, programmatically capabilities to list what sessions are connected, what they're doing, what they're subscribing to. When are they disconnected? What process happens when a session disconnects? Is it mission critical? Let's reconnect. There's session retries. And each session has the ability, if they're entitled, to have custom properties. Maybe we want to see what those custom properties are by session centrally and manage that. This is a security framework that's managed centrally and then distributed. So when we start to look at and kind of wrapping up this consumption, we have currencies, we have different tiers under the specific currency, and then we have currencies under tiers. And so these speak to the data requests, streaming requests by specific and focused applications to give the right data to the right consumer in real time. So here with the distribution of data and the extension of data to internet scale by diffusion, I've already described the deltas and the delta streaming and the savings with that. I've already described the mapping capabilities, the topic views to route specific or create specific views with just the data that that particular consumer wants to see or is entitled to. It addresses security issues as well. Maybe you're subscribing to a larger Kafka topic today that may have data that you may not want distributed to that particular client. It introduces the throttling and delay features that I spoke about earlier. We have the ability through conflation services to only send the latest version. And then when I spoke about the diversity of environments, on-premise, in cloud, as a service, Diffusion natively has topic replication services. Now this enables a lot of use cases. It enables topics to be synchronized across multiple different deployments, no matter what infrastructure you have, no matter how hybrid it is, and allows you to create fan-out strategies for distribution of data to a large number of concurrently connected users using our topic replication services. And this is managed internally, diffusion to diffusion. It's configured visually, and it ties directly into our topic views. Very powerful, eliminating the overhead of additional infrastructure and applications and custom coding to get this done with other solutions. So as part of the distribution side, delivery side, we're also looking at the operational side. And so we provide visibility through APIs or through our interface, through our console interface, of seeing data, let's say about topics. So built-in metric collectors that maintain performance metrics. So you can see here, I can show how many Delta updates went out to that particular consumer, what the cumulative values were. I can see here, for that particular consumer, our compression ratio, our Delta streaming ratio was well over 98%, reducing network bandwidth requirements and improving the operational efficiency of that client application code. You can see the number of subscriber updates, bytes, etc. Now, I can also create specific views, specific collectors of this. I may only want to see what's coming out of Kafka. I may only want to see what data is going to a specific consumer. I may want to see this organized by different topics. And so we have the ability to create fine-grained metric collectors that will give you the same data depending upon that topic. It could be applications, it could be data, it could be users. Now on sessions, we have the same ability to configure those custom metric collectors. And now we can see, now here I just took a snapshot of my environment. My Kafka adapter, I did not have connected at the moment, but I do show that I had some inbound messages, bytes, outbound, okay? And I can start to see data by principal, by user, by sessions, what they're doing, whether they're connected or disconnected. And I have that same visibility. Now we also provide a dashboard, okay? So basically it provides visibility into the operations and health of that environment. Monitoring is a strong value add to Kafka deployments, and the ability to get these visualizations to potentially Kafka topics, to applications that are connected to Kafka are critical. And so here with our dashboard, we have a lot of instrumentation. I just picked 3. So the load average, session messages that are occurring, and then the sessions themselves, okay? So you can add custom collectors inside of our dashboard as well. You could add collectors for the data. I can show business data as well. You can add collectors for internal Kafka topics as well to collect metrics about the operation of Kafka itself and visualize it centrally inside of our Diffusion console monitor, as well for the health and operation of how you distribute data at scale. So this is also accessible via an API. We have integration directly with Prometheus as well. So summary for the delivery. Diffusion's patented Delta streaming reduces data volume, changes in diffusion, addition or removal of topics, security rules, adding consumers or notions of consumer groups do not require scheduled downtime for diffusion as it does for other log-based types of solutions. Your enterprise is consistently up and available. There's no requirement to add architecture and process to prevent that for other types of solutions. And this gets back to where, we start to think about how we segment roles and function across the different brokers inside of our overall EDA for the efficient delivery of data to meet your customers or your requirements, your SLAs and your applications, okay? So it's getting to choosing the right broker inside of your EDA architecture. Diffusion extends Kafka to multi-protocol consumers, right? Across applications, but also over the web, over the internet, and mobile types of applications. And I can see I've missed one here. IoT types of consumers, IoT types of devices. Maybe you want to have IoT devices begin to work with Kafka itself and start to collect log data from those devices, supporting maybe a protocol like MQTT. Diffusion can act as that ingestion process for Kafka as well to collect IoT types of data. I kind of vary a little bit off my use case here, but I just wanted to show how open Diffusion is to many different types of use cases. So Kafka and Diffusion together, a game-changing technology stack. Kafka, very efficient with logs. Diffusion, very efficient with dynamic and unlimited topic structure. Natively always on, centralized security, reduced code, reduction of that human element, of that coding element, streamlining of that, reduction of infrastructure and network for your distribution requirements, extension to internet, I got IoT here, internet, IoT, and mobile itself, and simplification of Kafka cluster environments themselves. So business benefits, improved agility, increased innovation, addition of new markets for our use case, reduced TCO, simplified and expanded security, reduction of security infrastructure, distribution at internet scale. So I invite you to please learn more and next steps with Diffusion. We have a site specifically for integration with Kafka. It's go.pushtechnology.com. You'll find a step-by-step tutorial with sample code. You'll also find additional webinars. We have a couple of additional webinars out there about integration with Kafka. Let's say the process for connecting to Kafka from our cloud service. There's a very technical presentation that will walk you through that. We also have another presentation that talks about wrangling of data that comes from Kafka. And then I invite you to please try Diffusion in cloud for free. Please connect to dashboard.diffusion.cloud. And you can begin using us very rapidly. Pricing information for Diffusion downstream after free is available online as well. Thank you very much.